Okay, so here's part B. There was a tricky little fact in here that or two facts really. One is that this point Q is outside of the triangle. And I'll just say the other one is this line here, this line segment PB is inside the triangle. So it's interesting, you proved these two different ways, which is actually really cool to me. Because you could have extended BC like this and dropped a perpendicular down and had used the way what you did for AB for BC. And you could have also drawn a 90-degree angle right here and done the same thing for AB that you did for BC. But you did it two different ways, so that's neat actually. So I'm glad you did it two different ways. But you implicitly used the idea that, say, BP was inside of the triangle, and you implicitly used that BQ was outside of the triangle. So how do we know that's true? Let's look at BP being inside the triangle. Why is this 90-degree angle there inside of that triangle?
Well, I said it went down to a vertex.
Okay.
And this vertex is right on the triangle.
All right.
And then, like if it were here, then that would be outside it.
Well, we've got to be careful because let's draw another picture over here that's kind of the same triangle. Let's say I want to draw to this vertex a perpendicular that comes from the opposite side here. All right? So you're saying it's because I came from the opposite side to a vertex, I must be in the triangle. Well, what if I want to try to come perpendicular from the opposite side to this vertex? Where am I going to end up?
Well, to the vertex, you'd have to start from here. Well, it's kind of hard to see. You'd have to extend it outside.
Yeah, I'd have to extend it outside. So sometimes if I do, once I extend outside, then I can come perpendicular. So I'm not always going to be in the middle here. So it's not that I came from an opposite side to a vertex, because here's an example of where that would be outside. There's some other reason why this is inside.
But even if it were outside, wouldn't this proof still work?
Maybe. Maybe. But I want you to see why this has to be inside. Look at the problem. What was specific in this problem?
Well, this is an obtuse angle.
That's an obtuse angle. Okay, so how does that help?
Well, we're trying to prove that this is the longest side.
Yeah, well right now we're trying to prove why this BP is inside the triangle. That's all we're trying to prove. So why does the fact that that's an obtuse angle help us show that this is inside the triangle?
Well, if it were an acute angle, like if the triangle looked more like this, then it wouldn't, then B wouldn't be in the this BP wouldn't be there.
Why not?
Because it's not enough angle to fully cover it.
To cover what?
To make this be inside, because you have to extend the angle.
Until you get to where?
Until you get to BP.
Okay, what is the angle at BP?
It's 90. Okay,
this is a 90-degree angle. So if this is an acute angle here, at angle B, what's the problem?
There's not enough angle to do it.
To do what?
To have this be inside.
To have what be inside?
To have BP be inside.
Why is there not enough angle?
Because BP is a 90-degree angle.
Because BP is a 90-degree angle. Okay, but I don't have an acute triangle.
You have an obtuse triangle, which is a greater than 90 degree. This is greater than 90 degrees.
Okay, so what does that mean?
That means there is enough room to have BP be a 90-degree angle.
Okay. So in an obtuse triangle, I can cut off 90 degrees from this and still have something left over on this side. So I have something on this side, I have something on this side. So I go up and I'm inside the triangle. Okay? So the key point of why this was inside the triangle is this is an obtuse angle. Okay? Now, see if you can figure out why this is outside of the triangle.
Well, because this angle is less than 90. This is an acute angle.
Okay.
So if you made this part obtuse, like that, then it would be inside.
Okay. I'm not sure what you mean there.
Like if we slid B over here, then point Q would be inside.
Okay.
But we can't, B has to be over here.
B is, right, B isn't moving, it stays right there.
So angle C is, and we said it was an acute angle.
Yeah, well, okay, why do you know it's acute?
Because if it were 90 or greater, then the sum of the angles in the triangle would be greater than 180.
Okay, because this angle is greater. Alright, so what do you need to do?
I need to... We need to show that this is outside.
Yeah, okay. Why is that outside?
Well, because side AB isn't long enough. Because if B were over here, then it would be long enough.
Okay. What's the problem?
The problem is that this angle is too small.
This angle is too small. Okay? What do you need for this to be a 90-degree angle in terms of this angle here?
Well, you need this angle to be 90 or greater.
Probably getting close to 5 minutes here.